Let me see. I could actually change my, since now I have I want to change this. Let's see how it looks for 10. Because we actually have a value, and it's coming out to be about, it's saying 0.928, but that's not the value we want to use for our average displacement. Our average displacement is actually coming out to be 10, 5, I mean, 0.10571. If you remember from the measurement in the last video. So, I mean, it's essentially what we have here. This is beautiful, absolutely beautiful. Now that we have 10 degrees, we want to go ahead and get 30 degrees. So very excited about this. So we need to do the same thing. Always open up your columns, please, so you can see what you're hiding. Hide time, hide your x and your y velocity. And we might want to check the integrity of our data, 0.99, 0.99, 0.99, 0.99, 0.1. All right, that's good. So let's just go ahead and select on B and C. I'm going to copy that. And then go back to our alternative hypothesis, brass here. You might want to select some names that would be a bit more representative, but it's totally up to you. We're going to paste. And notice that we need to get rid of 14 through 21. So let's just delete everything there. And lo and behold, look at what we have. We have our average x displacement and our average y displacement. We're going to need both of them. We're going to use something different for our y displacement. We have it up on the board here. And so the one that's on the board equals to 0.05208 plus 0.10523. So I didn't do this in the last one, but I want to do it here. And I'm going to make sure that it's a negative value. So we're going to refer to this. So I'll put a negative, open parenthesis, close parenthesis, to match what we have here. And just to be consistent, I'll do the same thing here. This is equal to a negative, open parenthesis, 0.10571, close parenthesis, and now we're going to have, so now we need to go back to our extrapolation template and notice that at 30 degrees, we're going to have what's equal to a negative, and I'm choosing the thing that we actually measured with the micrometer, the height that was actually measured with the micrometer. And our displacement is going to equal to, and I have to slide over to the 30 degrees, 0.995. So you'll see that we're getting some different kinds of numbers here. And we're not referring to what's happening over here, and we need to refer to these two. Yep. So right now, you know what, I'll leave that just, no, I'll change it. So you'll see that J2 is referring to this empty cell right here. And I can, you know what I'll do? I'll go to J2 and I'll say equals to, for now, this value. And then I'll go to J24 and say equals to this value. That way we'll get some error on the side based on our theory, but we'll end up changing our theory since we have some measured values here. Okay, so let's continue right on. We have our next one is at 1.5, and let's see what we have here. This is going to just equal to this is at 45 degrees. Oh, we haven't put our data in yet. So let's go and get our data first. So this is number 3. We'll do the same thing. Get rid of time, get rid of D and E, and we're just going to take B and C. But let's check our data first. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, that looks good. So B to C, copy that, send this back, go back into our original file here, and just paste that into 45. Paste. So everything is coming out looking lovely, and our average displacement here is equal to a negative, and we have 0.05208 plus 0.13486. Close that. Back that. All right, so we're getting 0.18. So now we'll just go back to our extrapolation page, and this is going to be equal to a negative of that negative 0.18694. I'll drop this down. You'll see that we have that there. I am going to make both of these red because we're going to use that to interpolate. And then we have this is going to be equal to what we found on 145, and that is located right here. So we'll drop this, and notice what happens to our error. Our error is just increasing more and more and more. Okay, so we're going to deal with this as we go out. In other words, our experiment is good. Our hypothesis is good between 0 and 20, but it starts to deviate after that. All right? So in the next video, we're going to interpolate to make a correction so that we can have an alternative hypothesis. In other words, this hypothesis fails after 20, or at least around 30. It begins to fail around 30, and it really gets bad around 45.